Hello everyone and welcome back to Math 150 Quantitative Reasoning Mathematics. In the previous video, we used sets and Venn diagrams to organize groups, unions, and intersections. Today we're using a simple process, a simple problem-solving process that not only just applies to mathematics, but to everything. Okay, and this is the problem-solving process. Understand, solve, explain, estimate, and check. All right, I've taken the liberty to go ahead and work this one out, so I'm just going to be explaining this to you in this video. Okay. So the first question says a family drives 420 miles on 14 gallons of gas. Identify the quantity requested when asked for average miles per gallon and list the known units. Okay, so what we're comparing in this, or what we already know, is we know that the distance is 420 miles. We know that the fuel is going to take us, or excuse me, the fuel that the car has is 14 gallons. So in order to find the average miles per gallon, we're going to take miles per gallon as an equation and we're going to set it equal to miles over gallons. Okay, so miles per gallon means the ratio of miles to the gallon. We already know the distance. We're going 420 miles, or we can get 420 miles on 14 gallons. So this means we're going to basically accumulate 30 miles per gallon. Okay. So all we need to do is basically divide the miles by the gallons, and we pretty much got our solution. Okay. The next question is example number two. A phone plan charges a fixed $35 plus $8 per gigabyte. Write a plan for finding the bill when 6 gigabytes are used. Okay, so we already pretty much have our equation. The bill is going to have this fixed rate, so that's $35 plus $8 per gig. So that's essentially 35 plus 8x, okay, where x is the gigabytes used. So the bill is going to be the fixed rate plus the usage charge. That's 35 plus 8x, 35 plus 8, and then I substituted x for 6 because the x represents the gigabytes used, and we're going to use 6 in this question. So the bill is equal to $83 after we'll say before taxes, okay? And that is the conclusion of this one. All right, the next problem is a grocery bill includes $38.75, $19.40, $42.10. Estimate the total first, then explain how the grocery checks a calculator result. Okay, so if we were to estimate these prices, this is close to $40. So $40, that's close to 20. That'd be $60. This is close to 40 as well, closer to 40 than it is to 50. So total, we're looking at $100 as an estimate. If we add these together, so the estimate would be 100. If we added them together, we would get $100.25. Okay, so look how close the estimation is versus the human calculator. Okay, because I calculated these on my own. 5 plus 0 is 5. 7, 4 makes 11, plus 1 makes 12. 2 carry the 1. 9 and 8 makes 17. 17 plus 3, that's 0. Carry the 2, that'd be 20. And then 5 plus 1 is 6, plus 4 is 10. So 10, $100.25. So again, the estimation and the calculator are very close estimates. So the estimation is a very reasonable estimate. All right, let's continue. Example number 3, I looked at a problem, right? A problem, it says a calculation gives 0.18. Write two different interpretations when the quantity is a probability and when it is 18% tax rate. So again, both numbers are the same, 18%, 18%. One is the probability of the event occurring, that is dealing with probability. And then one is dealing with the tax rate. So the probability of an event happening, an 18% chance of it happening, contextually, that means something totally different. That, the odds of this happening is pretty low, right? There's close to a 20% chance. That's 1 in 5. Whereas the tax rate, 18% tax, that means about 20% of your money is going to be taken off of the top, or 18% is going to be added to your bill. Okay. So contextually, those two things mean two different things. All right, example number 4. A student uses a proportion while another uses unit analysis to convert 72 miles per hour to miles per minute. Compare the methods in units. Okay, so 72 miles per hour, if we were to convert this to miles per minute, right? We know that in 1 hour, you have 60 minutes. So if we were to convert this 72 miles over an hour, right? 72 miles per hour, we would multiply that by 1 hour, or 1 hour over 60 minutes. Doing this, notice how the hours cancel out because it's like 1 hour compared to 1 hour. So that's going to cancel each other. That leaves us with 72 miles over 60 minutes, which is what we have here. 72 miles divided by 60 minutes. When we divide these two, we end up with 1.2 miles per minute. And how do we interpret it contextually? That means at 72 miles per hour, we are traveling at 1.2 miles every minute, which is quite fast. Okay. Common mistake: a student reports the answer as 45, but the question asks for dollars per month. Correct the response. So notice they didn't put any units on this, right? Reporting the answer is 45. 45 what? Right? Notice when I do it, I wrote $45 per month, okay? Or $45 a month. So this is the unit rate that you want. $45 per 1 month, or $45 um or $45 per gallon, $45 the 45, I'll say 45, $45, 45 miles, 45%. I mean, there's a lot of different units that we can use. 45 square feet, dealing with the area, etc. Okay, so units make a huge difference. Always make sure you understand the units being used. Make sure, like, if you're converting and making conversions, that you end up with the units that you're looking for. Okay, so we're looking for miles per minute. So notice how after we solved, we ended up with the units that we wanted. Okay, so this process is very effective. Understand the problem, estimate if you have to, solve the problem, be able to explain it, and then check your answer. But always include the units. Okay, very, very important. In the next video, we'll work with fractions, decimals, and quantitative comparisons. And again, thank you for watching.